Today's daily code problem of the day is reverse odd levels of a binary tree, number 2415. For this problem, we are given the root of a perfect binary tree, and our goal is to reverse the node values at each odd level of our tree. So for example, if the node values at level 3 are 2, 1, 3, 4, 7, 11, 29, 18, it should then become the reverse order of that. So we want to return the root of our perfectly reversed tree. A binary tree is perfect if all parent nodes have two children nodes at the same level. So 2 has 2 children nodes at the same level. 3 has 2 children nodes at the same level. 5 has 2 children nodes at the same level. A level of a node is the number of edges along the path between it and the root node. So basically an edge is a connection between a node and another node. So 2 has one edge from 2 to 3. So 3 is on an odd layer. 3 has a second connection to 8, a second connection to 13. 5 has second connection to 21, second connection to 34. If we had another node down here for 34, this would be the third connection, making it an odd layer. So, taking that into consideration, our goal is to only flip odd layers. So when we have an odd connection amount, we're going to flip those two nodes. So 3 will go to where 5's at, 5 will go to where 3 is at. Now let's take into consideration, let's say that this bottom row is our odd row. How are we going to reverse this row? Well, if we look up here, we're going to see that it's not just the two nodes themselves that are flipped, it's the entire array of nodes. So 8 is going to flip with 34, 21 is going to flip with 13. So it's going to completely reverse the order of the nodes, not just flip the nodes based off of who their parent is. Taking that into consideration, how are we going to approach this problem? We will solve it using a recursive symmetrical traversal, meaning we're going to recursively traverse both sides at the same time. That way we can flip when necessary. So at every odd level, we will swap the values of our corresponding nodes in the left and right subtrees. We're going to have a base case, which is going to stop our recursion when we hit a null node, meaning we've reached our last leaf. We've gone out of bounds of our tree. Recursively, we will then swap, and for each odd level, we will swap the values of the paired nodes, the left and right children, and continue recursively for their children. So we will recursively swap the children until we reach our desired output. But we're not just going to swap there. We're also going to swap the fact that they're the children of 3. We'll swap them to be the children of 5. So 5's children will go to 3, and 3's children will go to 5, efficiently making, let's say we're swapping this bottom row again. It's going to be 13, 8, 34, 21. So, by swapping the nodes with their brother or sister, and then swapping their parents, we're efficiently reversing that layer. So, let's go ahead and jump into this solution. So, in our main function, we are simply going to call to our helper function. It's going to be a level traverse, and we're going to pass it our root.left and our root.right and the number 0. 0 is going to represent the level that we're starting. After our helper function, we can simply return root, as that is going to be the root node of our it's going to be the root node of our new tree, as well as the old tree. So for our helper function, we're going to define a private void called level traverse. It's going to store a tree node called node 1, or the left node, and tree node node 2, which would be our right node, and then our integer level. In this helper function, we will define our base case. If either of these nodes are equal to null, we can break because we've reached the end of our tree. So if node 1 is equal to null, Or node 2 is equal to null. For whatever reason, node 1 wasn't. We can return. Otherwise, if we're on an odd level, we will swap the values. So if level modulus 2 is equal to 0, meaning that there's no remainder, we can then, so the reason that we're identifying if it is an even layer is because we're starting at layer 0 and we're not incrementing it before we hit our first node. So, I can draw it. Here is layer 0. However, we're starting at root.left and root.right, meaning that we're identifying this as our layer 0, right? So this is layer 0, and then we're going to go down another level, and then we will increment our layer by 1. This will make this layer 1. However, we want to flip this layer and the next layer, not layer 1. So we're going to identify them as evens rather than odds, simply because of the way that we inputted this. Let's say we inputted 1 as our initial value. We would put, as long as it's not equal to 0, but we put 0 as our layer, so we can check it as every even. So we're going to say if level modulus 2 is equal to 0, then we are going to swap our nodes. So int temp is going to be equal to node 1.val, and node 1.val is going to be equal to node 2.val. Node 2.val is going to be equal to our temp value. And that's it. Then we can recursively traverse our left and right children by calling our level traverse, passing node 1.left, node 2.right, and increment level plus 1. And then we can do the same thing, but for the opposite nodes. So level traverse, node 1.right, and node 2.left, level plus 1. So this does the same thing that we were talking about, where we swap the parent nodes and the children nodes to get our desired output. So if we run this, pass our test cases, and if we submit it, passes all solutions. Thank you, and follow for more daily LeetCode solutions.